Have you ever looked at a list of numbers and just felt completely lost, like you're drowning in data? Well, today that's going to change. We're going on a journey to become data detectives, learning how to uncover the secret stories hidden inside the numbers. Ready to crack your first case? Let's get started.
Here's a quick look at the detective's toolkit we're building today. First, we'll figure out what statistics even is. Then, we'll learn how to properly gather and organize our clues. After that, we'll see how to visualize them to spot patterns. And finally, we'll learn how to find the usual suspect in any set of data.
All right, here's our first case file. Take a look at this. It's the math scores for 30 students. Right now, it's just a jumbled, chaotic mess of numbers. I mean, where do you even begin? Well, believe it or not, for a data detective, this is the perfect place to start.
So, what's the secret weapon we're going to use to sort this out? It's called statistics. You can think of it as a science of learning from data. It's the powerful set of tools that lets us turn all that chaos into clarity.
First, what are our clues? In the world of statistics, we call them data. Data is just facts or figures we collect for a reason. In our case, the test scores are our data. Think of them as the fingerprints and witness statements of our investigation.
And statistics? That's the entire detective process. It's not just about having the clues. It's the whole shebang, from collecting the evidence to organizing it on your board, analyzing it for patterns, and finally interpreting what it all means to solve the case.
Okay, first things first. Just like any good detective, our first move is to gather all our evidence and get it organized. You can't solve a mystery if your clues are scattered all over the floor, right?
Now, when it comes to gathering clues, there are two main ways to do it. You can collect the information yourself. That's called primary data. It's like first-hand evidence. Or you can use info that someone else already collected, which we call secondary data. That's kind of like reading another detective's report.
Remember that chaotic list of scores? Let's bring some order to it. We're going to create something called a frequency distribution table. It's easy. We just list each unique score, then go through our original list one by one, making a simple tally mark for each score as it appears. Once we're done, we count up the tallies. It's a super simple but really powerful way to sort our evidence.
And voila! Look at that. Suddenly, the chaos is gone. We've got a clear, organized table. This isn't just about being neat. This is about revealing the story. We can instantly see things we couldn't before. Like, it's now crystal clear that 4 students scored a 40 and another 4 scored a 70. This is way more useful than that long, messy list we started with.
Okay, our clues are organized. What's next? It's time to make them visual. Think of a detective's evidence board with all the photos and strings connecting them. Seeing the data in a graph helps our brain spot connections and patterns that we might miss just by looking at a table. This is where the bigger picture starts to emerge.
Now, two of the most common tools for this are the bar graph and the histogram. They look really similar, and a lot of people mix them up. But here's a pro tip: they are not interchangeable. A good detective knows they're used for very different kinds of clues. So what's the difference? It's actually pretty simple. Bar graphs are for categorical data, things that fit into distinct groups, like months of the year or favorite pizza toppings. Notice the spaces between the bars? That's key. Each bar is its own thing. Histograms, on the other hand, are for continuous numbers, like height or time. The bars touch each other because the data flows from one interval right into the next.
Okay, pop quiz time. If you wanted to show the number of students born in each month of the year, which graph would you use? Go on, pause and think about it for a sec. Got it? If you set a bar graph, you nailed it. Why? Because each month, January, February, March, is a separate, distinct category.
All right, now for the main event. Our data is organized, it's visualized, now it's time to find the heart of the story. We need to find the typical value. And for this job, we have 3 main tools, our 3 usual suspects: the mean, the median, and the mode.
First up is the mean. You almost certainly know this one already. It's just the good old average. You add up all the numbers, then divide by how many numbers there are. Simple and super common.
Next, we've got the median. The key word here is middle. The median is all about position. You line up all your data points from smallest to largest, and the median is the value that's sitting smack dab in the center.
Now, finding that middle value has a little trick to it. If you have an odd number of data points, it's easy. There's one number right in the middle. But if you have an even number of data points, you'll have 2 numbers in the middle. No problem. You just take the average of those 2, and that's your median.
And our third suspect is the mode. This one is by far the easiest to spot. The mode is simply the value that shows up most often in your dataset.
That's it. It's the most popular kid in the class.
So, we have our 3 suspects lined up: mean, median, and node. But here's the million-dollar question. Which one tells the truest story? This is where a data detective really earns their stripes, because picking the wrong one can lead you way off track.
Let's look at a new case. We've got a small factory with 5 employees. 4 of them are laborers who each earn 5,000 rupees. But look at this. The supervisor makes 15,000 rupees. That one value is really different from all the rest. In statistics, we call that an outlier.
Okay, let's run the numbers on this. The mean, or average salary, is 7,000 rupees. The median, the middle salary when we line them up, is 5,000. And the mode, the most common salary, is also 5,000. So what's the typical salary here? Does 7,000 rupees really feel like it represents what most people earn?
And here is the aha moment. That mean of 7,000 rupees is totally misleading, isn't it? It got dragged way up by that one high supervisor salary, by that outlier. This is the crucial takeaway. The mean is very sensitive to extreme values. The median and the mode, however, are not. In this case, they give us a much, much truer picture.
And that, right there, is the most important lesson for any data detective. The mean, median, and mode are all useful, but they can tell very different stories about the exact same set of data. The real skill isn't just knowing how to calculate them, it's understanding your data well enough to know which tool is going to lead you to the truth.
So, I'll leave you with a final case to solve on your own. Think about your scores from your last 5 exams. Which measure would you use to describe your performance? What if one of those scores was really high, or maybe really low? What different stories would the mean, the median, and the mode tell about your work? Time to do some detective work of your own.